The original source of energy is what? The sun. Then plants use the sun's energy during photosynthesis to convert water and carbon dioxide into sugar and oxygen, and they store the energy in the chemicals that the plant produces. When animals eat plants, the energy is transferred to their bodies. So then, the plants and animals die and decay, and they sink to the bottom of the sea or disintegrate into the soil, and then they recovered by more and more sediment as rivers deposit mud and sand into the sea or the seas advance and retreat. Of course, it's a very gradual process, one that takes place over, well, millions of years. But finally, the organic material begins to transform into the hydrocarbons, and the hydrocarbons eventually become oil and gas deposits. So how does this happen? Well, at first, the oil and gas are mixed with sand and sediment, but, as the layers on top increase, then so does the pressure. And under pressure, mixtures of oil and sand and water, they seep down through the layers of porous rock, that's usually sandstone or limestone, so they sink down until they reach a layer of non-porous rock, and that's where they pool because they can pass through the non-porous rock. Okay, sometimes there are breaks in the layers of rocks, and the breaks allow oil and gas to bubble up, and eventually they reach the surface of the earth again. So, when this happens, the gas and some oil evaporate in the air, but they leave a sticky black tar that appears in pools or pits on the surface. But most crude oil is found in underground formations, which we call traps. So today, I want to talk about the major types of oil traps. In all the different types of traps, the oil collects in porous rocks, along with gas and water. And, over time, the oil moves up towards the surface of the earth through cracks and holes in the porous rock until it reaches a non-porous deposit, and the non-porous rock, remember, it won't allow the oil to continue moving. So, the oil becomes trapped under the non-porous rock deposit. Now think for a moment. While oil was forming and moving, the earth was also undergoing changes. In fact, there were enormous movements of the crust as the center began to cool. When folding happened, well, it was like the earth fell back onto itself. And when faulting happened, it was, well, one layer was forced by rocks above down through the layers below. So, you can see that the repositioning of porous and non-porous rock, this repositioning would have affected the movement of oil. When the earth shifted, cracks would have been opened, and non-porous layers would have been dropped over channels that had previously been used as pathways for the transfer of oil and gas to the surface. Okay, as geologists, we're interested in locating traps. Now why would that be so? Because that's where we'll find the oil and gas reserves. And that's what I really want to talk about today. So, there are several different types of traps, but today we're going to talk about three most common ones: the anticline trap, the salt dome trap, and the fault trap. Look at this diagram. Here's an example of an anticline. As you can see, the oil is trapped under a formation of rock that resembles an arch. That's because the arch was bent from a previously flat formation by uplifting. In this anticline, the petroleum is trapped under a formation of non-porous rock with a gas deposit directly over it. This is fairly typical of an anticline. Because gas isn't as dense as oil, it rises above it. The dome over the top can be rock as in this example, or it could be a layer of clay. The important thing is that the cap of non-porous material won't let the oil or gas pass upwards or sideways around it. Now let's look at next diagram of a salt dome. The salt dome shows how a cylinder-shaped salt deposit has pushed up through a layer of sedimentary rocks, causing them to arch and fracture. The oil deposits have collected along the sides of the salt dome. Salt is a unique substance. With enough heat and pressure on it, the salt will slowly flow, kind of like a glacier, but unlike glaciers, salt that's buried below the surface of the earth can move upward until it reaches the earth's surface, where it is then dissolved by groundwater or rain. Well, to get all the way to earth's surface, salt has to lift and break through many layers of rock. And that's what ultimately creates the salt dome. Finally, I want to show you a fault trap. Fault traps are formed by the movement of rock along a fault line. This diagram represents a fracture in the earth that has shifted a non-porous rock formation on top of a porous formation. In this case, the reservoir rock, which is porous, has moved opposite a layer on non-porous rock. The non-porous rock prevents the oil from escaping. Remember, as in all traps, the oil is collected in the porous rock and trapped underground by the non-porous rock. Geologists study the terrain for indications of possible oil traps. For example, a bulge in a flat surface may signal the presence of a salt dome. You can read the Oil and Gas Journal to find more on how technology assists the geologists in this effort.